All right, in this video, you are going to learn how to write up your one sample t-tests. All right, so let's imagine that I'm going to consider if my school, let's say I go to Mount Juliet High School, and I want to know how does this average of scores compare to maybe the national average. So I actually have a data set in my JMP where I list all the different kiddos and have all of their ACT scores. And I want to know, hey, is this statistically significantly different than the national norm? All right, so I just look up, I actually literally Googled what the national norm is. So a research question might look like, is there a difference in ACT scores between Mount Juliet High School students and the national average, or I should say their student scores and the national average. So notice that the independent variable are the two schools. Okay, it's Mount Juliet High School and the national average. So it's those are the groups. So it's one group against this national average. That's the independent variable. The dependent variable is what I'm measuring, the ACT scores. So that's a pretty specific that's a pretty specific research question. And so if I'm going to make a null hypothesis for this, I'm going to say there's no statistically significant difference in the dependent variable in ACT scores between Mount Juliet High School and the national average. So conceptually, what am I doing here? All right, so JMP will do the math for me, and it's going to churn out a T. Now, in null hypothesis world, the differences between the means would be 0. There would be no differences. And so remember, this is a null model. This is showing me that if T is 0, that's exactly what I would expect in a null hypothesis population. But I'm wanting to know, hey, is this like a white squirrel kind of thing? Is this like a unicorn? You know, something I would totally not expect to see. Where, like, if the differences were big between those two mean scores, that would be quite rare. That the number that comes with T would be big, and it would like fall way up here above a 2, or it'd be really low way down here, and that would be very unlikely. So that's in essence what I'm looking for, what this T value tells me. Now I'm going to go on and write out my alternative hypothesis just so you understand what I'm doing. What do I, as a researcher, expect to see? Well, I expect to see that there is a statistically significant difference between ACT scores and Mount Juliet High School scores. Between the two groups, Mount Juliet High School, and the national average. That's what I'm comparing. So I'm actually going to set my alpha level at a 0.05 because my sample is 56, okay? Now if my sample was above 250 or 300, I'm probably going to change my alpha to a 0.01. That's very important for you to know for your homework, okay? Consider how many participants are involved here. All right, so I have a pretty small sample. Now I've got to go through my assumptions, and to review our assumptions, we're going to assume that this is from a random independent group. All right, we're just going to assume that. Next, I need to check for normal distributions. Well, the reported skewness was 0.59, so that is great. I don't even have to look at kurtosis for that, so that assumption is met. I don't have to worry about assumptions for equal variances because it's a one sample t-test and there's only one sample to look at, so there's no way to really look at, there's really no way to compare variances. So I can just go on and run my, conduct my t-test, and there's another video showing you how to do that on JMP. But you'll have something churn out that looks like this. So when I write this up, this is what I think the tricky part is for everybody. What do I actually write? Okay, so especially in your homework for this course, you have to spell out the skewness that you find and kurtosis if that's even necessary, okay? So you would need to write up skewness was 0.59. I got that right here. And that assumption was resolved. And then you're probably going to write a little narrative and say something like, really you don't need a table here, but I have it in here just so you would know how to set it up in APA. But if it's just one small finding from one t-test, you really don't need a table. But in your narrative, you would say a one sample t-test revealed that students at Mount Juliet High School had higher ACTs. Actually, let me, they did not have higher scores. They actually had comparable ACT scores because, look at this. The p-value here associated with the t-test, this is the one I'm looking at, 0.14. That is not statistically significant. So because the national average was 20.8, and from my sample it was a 22.626, that's really not too different from each other. All right, so that's basically what this is saying. When they did the t-test formula, then they're like, the t-statistics was just a 1.48, which was really not too rare to find. So we would say that our sample is pretty close to the regular sample here, to the regular population. There's nothing special going on. But I write it like this: a one sample t-test revealed. Actually, let me show you this. You don't put a hyphen, and this would actually need to be italicized, okay? That students had comparable ACT scores compared to the national average. Now I have a T. Now what goes in parentheses is the degrees of freedom. The degrees of freedom are found right here, all right? And that should be, is usually N-1 or N-2, and you can kind of look at that and check. And I'd always have to look up what it is for each type of test, but it's generally something like N-1, N-2, so that looks correct. So I'll put that in parentheses, space, equal sign, space. This is the t-value. 1.48 is the t-value. It comes from here. And then the comma, italicize the p, space, equals, space, 0.14. I'm looking at this two-tailed test. I did not say what direction in my null hypothesis. I just said that there would be a difference in my null hypothesis. If I had said that Mount Juliet High School scores would be higher than the national average, I would have used an upper tail test. And actually, that would have almost been significant here. You see, because it's almost at a 0.05. Yeah, truly, almost Mount Juliet High School's average was higher than the others. But we didn't state that from the beginning. We stated a non-directional null hypothesis, just saying there would not be differences. So that's what I'm sticking to. All right, so most of the time you indeed will use a two-tailed test, and you're looking at this one, the one with the T with the lines. Okay, so the null hypothesis was retained at an alpha level. I'm going to believe my null hypothesis. There's nothing going on. It's the doldrums, nothing special. Now, if I did find a statistically significant difference, it would be very important to report the effect sizes and the power. But if I don't find a statistically significant difference, you don't even worry about effect sizes or power. But let's just pretend that I did find it, and so I did find a difference. So I'm going to go on and show you how you would calculate the effect size. There's all kinds of effect size calculators online, I like this one here. And so I go to the one sample t-test and I enter my sample mean for Mount Juliet High School compared to the expected mean, 20.8 of the population, the national average. And I put the standard deviation for my sample, set this confidence interval at 95. You actually don't even have to worry about what that is. Then it turns out the D, this Cohen's D value is a 0.19. I'm going to round that up to a 0.20. Okay, so if this were significant, I would say Cohen's D effect size, and D is always going to be italicized, reveals a very small effect. Now, how do I know that it's small? Because I've read in my statistics Hatcher book, he has it on a specific page, and I look it up in there. It tells me it's small. Then I will report the power. And so when I look at power on JMP, it says the power is 0.31. Okay, so I'm going to round that up, 0.31. And that indicates that this test shows that there's really only a 31% chance of correctly rejecting the null hypothesis. That's actually not very good. And that's really based on sample size and variance and other factors. But again, would I write this up if I found no statistically significant results? No way. But I'm just showing you this here just in case you do get statistically significant results, what to do. Now, if I would say that, if it was just ACT scores and that's all you compared, I don't think a table is necessary. This is exactly what you just said in your narrative. However, if you were looking at like, okay, I'm going to actually compare ACT English and then also ACT Math, and a few other dependent variables, okay, ACT Science, then it would make more sense to have a table with all of these. In your dissertation, it's not a good idea to just like have this same sentence over and over again when it's in your table. Instead, what you would do in your real dissertation is you just highlight maybe which ones were significant, and that would be a good thing, or which ones showed big effect sizes. So you don't just repeat everything you put in the table. Another thing to keep in mind when you write your real dissertation is you do not have to report skewness and kurtosis in your dissertation if everything is fine. If it's not okay, then you do need to report it. However, for this class, if you're doing homework assignments, you are expected to write skewness and kurtosis, or skewness out at least, and then if you need to, kurtosis, because we are making sure we want to know you know how to test assumptions. All right, so that is how to do a one sample t-test. Enjoy!